Hey guys, in this lesson we're going to take a look at areas of sectors of circles and area of segments of circles. So to start off with, a sector of a circle. It's a region of the area of a circle bounded by two radii and the included arc. So AC is one of our radii, and then BC is the other. And then, so two radii. In this problem we're looking at AC and CB. And then included arc, we're looking at arc AB. So it kind of looks like a slice of a pie. But like the definition said, it's the region of the area of the circle. So whereas when you work with the arc length, you're looking at a portion of their circumference. So we used 2 pi r as part of our formula. With this one, we're using part of an area. So when we're looking at area of a circle, that's pi r squared. But we don't have the whole entire area. We only have a portion or a fraction of the circle. So sector of a circle, they use K to represent the area of the sector of a circle. And the area of the sector of a circle is going to be equal to pi r squared. So the area of the whole circle times the fraction that you have. And in this case, whenever we're looking at the fraction of the problem that we have, we're doing theta over 360. They do it by the angle measure that you see right there. Okay, so that's your formula for doing these. So let's start trying these out. Looking at the two examples that we have for finding area of a sector. For these problems, they want us to give the exact answer in simplest form. And remember, whenever they say give an exact answer, that means there's going to be pi in the answer, or there could be. And if there is, don't multiply by it. And that's what they mean by the exact answer. Okay, so with this example, they say the radius of a circle is 6 feet. What is the area of the sector bounded by a 45-degree arc? So if we go back to our definition of the area of the sector of a circle, it's going to be K, or the area of the sector is going to be equal to pi r squared times theta over 360. So K is going to be equal to pi r squared times theta over 360. So the area of the sector is what we're solving for. That's our K. So if we're going to solve for K, we need a value for the radius and we need a value for the angle. So K is equal to pi times r's radius. They tell us that the radius of the circle is 6 feet. So we've got 6 squared times theta, and theta is the measure of the angle, and they say bounded by a 45-degree arc. So if this arc has 45 degrees, we know this angle also has 45 degrees because it's a central angle. And whenever you're looking at the intercepted arc and its central angle, we know they're going to be equal. So this is going to be 45 over 360. So the area of the sector, or K, is going to be equal to pi times 36 times, and I'm going to simplify the fraction 45 over 360. And that's going to give us 1/8. So I've got 1/8 times 36, and that leaves us with K is going to be equal to, and it's going to be 9/2. Well, if I show all the work, it's going to be 36 over 8 pi. But that's not a good answer because it's not simplified all the way. And if we simplify it all the way, it'll be 9/2 pi. So you would either put, and this is the exact answer because remember it asked for exact, so that means we do not multiply through by pi. So we can either put in 9/2 times pi as our answer, or you could do the decimal answer and do 4.5 pi. But either way, whenever you're doing area with an exact answer in simplest form, you got to make sure you put the pi in, or you won't. It's not considered correct. So looking at the next example that I have for you, in this problem, they gave you radius. And they can either give you radius or they can give you diameter. So this is an example of a problem that has diameter in it. So again, the diameter of a circle is 18 kilometers. What is the area of a sector bounded by 132 degree? And I think this arc is supposed to go over there. Okay. So if we look at this, they want to know area of a sector. So that goes back to our definition that we had for area of a sector over there. An area of a sector is going to be equal to pi r squared times theta over 360. So k is going to be equal to pi times, and the r stands for radius. So that means we have to have a value for the radius. Well, if we look at our problem, they don't give us a radius. They give us a diameter. So, but we do know radius is equal to diameter divided by 2. So the radius is going to be equal to 18 divided by 2. So our radius is going to be 9. So we've got k is equal to pi times 9 squared times theta. And theta is the angle, and the intercepted arc is equal to the angle. So we can use 132 over 360. So k is going to be equal to 9 squared is 81 pi times, and if you simplify 132 over 360, we get 11 over 30. So if we multiply 11/30 times 81, and simplify it, we're going to be get k is equal to 297 over 10 pi. So whenever I put this into the calculator, I do 81 times 11/30 and just remember to bring down the pi and put it times pi down here. You can put 297 over 10 times pi as the answer, or you can do 29.7 pi as the answer. Either one's okay. This is still an exact answer because you haven't multiplied by pi. Pi is a non-terminating decimal, which means it's never going to end. So if you multiply pi times the 29.7, you're going to end up with something that looks like, you're going to end up with the decimal that looks like this. And in order to be able to write this down, you would have to round it. I mean, this number right there could be rounded by the calculator for all we know. So that's what they mean by exact answer. Well, it's okay to have fractions and decimals. You're not going to multiply through by pi for your exact answer. Okay. Well, they could give you problems where they ask you to find the area of the sector. They could also give you the reverse of these types of problems. They could also give you the area of a sector and then ask you to find what is the measure of the arc. Okay. So with this one does the area of a sector. And that kind of follows the definition exactly. With this one, they are having you find an angle measure using the area of a sector. And you can plug everything into this equation and solve it through every single time, or you can take k equals pi r squared times theta over 360, and we can solve for the angle measure, just like we did in the lesson where we were solving for the angle measure whenever we were doing the arc length. So what I'm going to do first is I'm going to multiply both sides by 360 so I don't have a fraction anymore. So that'll leave me with 360k is equal to pi r squared times theta all by itself. And we're getting closer. We want the theta all by itself on one side, the equal sign. It's all by itself here without it being a fraction. But it's not all by itself because it's still being multiplied by the pi r squared. So if we divide both sides by pi r squared, I'm going to move theta over on this side. Theta is going to be equal to 360 times the area all over pi r squared. So you could use either to solve for the measure of the angle, but I think this one's going to be a little easier because all you have to do is plug the values in. So if we start solving this out, they want us to, what is the angle measure of the arc? So the angle measure is going to be equal to theta is equal to 360k over pi r squared. So theta is going to be equal to 360 times k. Remember, k stands for the area of the sector. So if we're looking at the area of a sector, here it's pi, it's 11 pi. So this one we'll write down, 11 pi over pi times radius squared. Radius in this case is 5. And I'm just going to start simplifying the values. Theta is going to be equal to 360 times 11. And 360 times 11 is going to give me 3,960 pi over pi times 25 squared. I'm just going to write the 25 in front. 25 pi. And we've got pi over pi, and pi over pi is a value of 1. So theta is going to be equal to 3,960 divided by 25. And that's going to give us 792, if we simplify it, 792 over 5 degrees, or we could also enter it as 158.4 degrees. Either one of those would be our right answer. Looking at the next one, it's the same exact idea as the last example we did. It's just in this case, they gave us a diameter instead of a radius. They're still asking us to find the angle measure of the arc. So with the area, I'm moving this over there, 8 pi meters squared. So area of the angle measure is going to be equal to 360 times the area of the sector divided by pi times the radius squared. So the measure of the arc is going to be equal to 360 times k. K is the area of the sector, and they tell us that is 8 pi meters squared. All we need is the 8 pi in there over pi times our radius. In this case, they don't give us a radius, they give us a diameter. But we know diameter is equal to the, we need a radius, but they don't give us a radius, they give us a diameter. And we know that radius is equal to diameter divided by 2. So radius is going to be equal to 16 divided by 2. Radius is going to be 8. So I've got pi times 8 squared. So theta is going to be equal to 360 times 8 is 2,880 over 64 pi. And I forgot about the pi up there. So 360 times 8 is 2,880 pi over 64 pi. Pi over pi has a value of 1. So divided by 64. And then theta is going to be equal to 45 degrees. So there's your couple examples, two where they give you the information and they ask you to find the area of a sector, and then this one they give you the area of the sector and they ask you to find the angle measure of an arc. So that's two different ways that they could have you use information on the sector of a circle. So now looking at the segment of a circle, whereas a segment of a sector of a circle is a portion of the whole entire area. A segment of a circle is this little area in here, AB. So that bounded arc and then that chord right there. With this, a segment is a portion of a sector, which is a portion of a circle. And I think a lot of people think that that sounds really terrible, but it's really not that bad. Because if you look at it as part of a sector, is being that whole part right there. If you look at the part that's not a part of it, or that's kind of been cut off so that you get left with the segment, look at what that shape is. What is that shape? Yep, it's a triangle. So what you do is you take, and I don't think there's a special abbreviation for the segment of a circle, so I'm just going to use A. A is going to be equal to pi r squared times theta over 360. Because we still have to figure out, okay, what's the area of the whole entire circle? Times what's the portion of that little sector that's been cut out? And if you look, now they're going to cut out a whole triangle. So minus the triangle, but it's going to be the area of a triangle because we're cutting out a portion of the area of the sector. And remember, the area of a triangle is 1/2 base times height minus the area of the triangle in the sector. And remember, depending on base times height, your height can be there and your base can be there. But for the problems, the majority of the problems that I feel like you have, you'll be working with a right triangle. So one of these will be your base and one of these will be your height. So your radius will be your base and your height. They could give you one where you have a base and a height here, but that I don't think they'll do that. So if we try this out on the example that we have, calculate the area of the segment, give an exact and approximate answer. So an exact answer, remember, is one with pi in the answer. An approximate answer is one where you multiply through by pi and you round your answer. Okay, so if we give this a go, calculate the area of a segment. Area of a segment is going to be equal to, well, you got to figure out the area of the whole circle, pi r squared. Then you've got to multiply it by the fraction of the circle that you have that you're working with, and that's going to be theta over 360 minus the area of the triangle that's been cut out, 1/2 base times height. So if we start finding all these values, area is going to be equal to pi times the radius squared. And in this one, the radius is 22. So we've got 22 squared times theta is the angle of the intercepted arc that we're working with. So that's going to be 90 over 360 minus 1/2 times the base. And with this being a 90-degree angle, that makes this one be the base and this one be the height. And honestly, it doesn't matter which one is which. And a lot of times I'll have people get stuck and be like, okay, they give me the height, but they don't give me the base. And I say, okay, well, just remember what you're working with. You're working with a circle. And if you go from there to there, that's going to be a radius. And if you go from here to here, that's also going to be a radius. And you've got to remember that all of the radii in a circle are all going to be the same exact length. So if this one is 22, this one is going to be 22 as well. So it's going to be 1/2. The base here is going to be 22 times the height is going to be 22 as well. Alrighty, so if we start simplifying things, area is going to be equal to 22 squared is 484 pi, and I'm doing these little bits and chunks at a time, times 90 over 360 is going to give us 1/4 minus 1/2 times 22 times 22 is 484. So now I'm going to simplify things some more. Well, using our order of operations, we have to do all the things multiply. We did the exponent part. Now we have to do the multiply things before we could add or subtract. So we've got to multiply 484 times 1/4. So area is going to be 484 over 4 times pi minus, here's a multiply here. So 484 times 1/2 is going to be 242. And then we need to simplify the 484 divided by 4. And that's going to give us 121 pi minus 242. And this is our exact answer, because remember, exact answer means it's probably when we're working with area, anything that has to do with circle, it's going to have pi as part of the answer. So we can't multiply through because then we would have to approximate. So there's the exact answer. Alrighty. And then they want the approximate answer. And the way you approximate the answer is you just put this in your calculator and solve it out. So I've got 121 times pi minus 242. And that's going to give us area is going to be equal to 138. And I'm going to do 2 decimal spots, 0.13. And our units on this is feet squared. Here's feet squared. Okay. And this is our approximate answer. Alrighty, so there's your example of how to find the area of a segment of a circle. You just find the area of the whole thing, multiply it by the part of the circle that you're actually working with, and then subtract off the triangle part that they've cut off. And then looking at the sector, they could ask you to find the area of the sector given information. They could also ask you to find the measure of the arcs or the measure of the central angles given the area of the whole thing. If you have any questions, be sure to write them down on your paper and ask whenever you get to class.